So what is this all about? What is the Princeton Web Transparency and Accountability Project? This is 2014, right? So I don't need to tell you what online tracking is. You've seen many, many times numbers like there are 64 independent tracking mechanisms on the typical top 50 website. You're jaded. You've seen all this. In fact, many, many speakers have thrown this slide at you of yeah, I see a lot of nods in the room already, of the display advertising technology landscape. This is a slide by Luma Partners. But things get a bit more interesting. Let me explain what these things are and why maybe these are not by themselves ideal. So on the left, these are browser-based blocking tools. AdBlock Plus, Ghosttree, you've seen them. Many of you use them. I don't have anything bad to say about them. I certainly use Ghosttree myself. I would recommend it. But here's why these browser-based blocking tools are never going to be the solution for everybody. For me, just anecdotally, when I use Ghosttree, when I'm browsing the web, about 20% of websites have some problem. Sometimes it's a subtle problem. Sometimes the functionality of the website that I'm interested in is broken in a fundamental way. So that's the reason why, even though in absolute numbers, tens of millions of people use these tools, it remains a very small percentage. There are new tools like Privacy Badger. I'll say a bit more about that near the end. But also I want to point out the way in which these tools are constructed. They come with massive filter lists of regular expressions that define what are all the possible URLs on the web that are trackers or advertisers, as the case may be, versus non-trackers. And these are constructed pretty laboriously. Funnily enough, I happen to be looking at the AdBlock Plus forum, where users can report if there is an ad that's not blocked by the tool. And that thread had 10,000 posts. So 10,000 times, right, users have noticed an ad not being blocked and reported it. And so there's this very cumbersome crowdsourced process of trying to keep these tools up to date. If you're talking about blocking these pixels or bugs or beacons or these invisible elements, right, that are the real cause of the online tracking issue, then the idea that humans can evaluate what are all the trackers on the web and keep them up to date and also succeed at not blocking legitimate functionality is probably never going to be achieved. So those are the purely technological solutions. On the other hand, you have, in the US, for example, the self-regulatory bodies, the NAI and the Digital Advertising Initiative. And you have the EU cookie law. And then, of course, there's Do Not Track, which I think can probably be best summarized by the phrase, could have been a contender, right? So again, I don't mean to diss any of these too much. They're somewhat effective, but far from complete solutions to the problem. Arguably, the organizations like NAI block some of the more egregious abuses, but roughly it comes down to, you can basically collect all the data you want, but just make some promise in your privacy policy about how you're going to use the data versus not use the data. But there's nothing really externally verifiable. So we started thinking, what if there could be something in the middle where you use technology to drive policy, or you enforce policy solutions through technology? What are some possibilities that point of view opens you up to? Online tracking was what we started looking at, but very quickly we realized that the problem has gotten much bigger than that. It's not just who's collecting your data, who are they sending it to, but really what people are concerned about is how this data is being used, and they want some answers to that. They want to have a way to control that, and so on. And so when you look at it like that, the problem becomes much, much broader. And I want to say that online tracking is a part of this. So what are the set of broader problems that we're looking at? There is, for example, the filter bubble. Right, the filter bubble, this is Eli Pariser giving a TED Talk. There's a whole book about it. This is the idea that websites are looking at what you read. And in order to maximize clicks, or for whatever other business imperative they have, they're feeding you information that's similar to what you've looked at in the past, is the claim. And this is leading to ideological bubbles where people are being fed more and more reinforcing views similar to the ones they already hold. So this is considered to be a serious problem with the web. Again, it's a type of use of personal data that is causing this sort of public outcry. And then Ryan Calo worries that digital advertising is a form of market manipulation. There are worries about price discrimination, where websites are varying prices and deals based on users' information. Right? And so not only are we moving past collection of data here to users of data, we're also moving past this notion of hidden third parties who you're not looking at when you visit a page who might be collecting your information, to what are the very websites that I'm visiting and who I'm giving my data to. How are they using my information? I want some knowledge about that. I want some control over that. So that's the full general scope of the problem that we wanted to kind of tackle. And what we realized is what I said in the abstract. Just like the Panopticon, And I think this is a pretty good analogy to think about this, because the problem here was not merely that the prisoners were being watched, but instead that they couldn't watch the watchers, and that there was this fundamental asymmetry. And that was what was giving it its truly dreadful character. And we think it's a similar problem online. Nobody's saying that all tracking by itself is bad, or even most tracking is bad. But what's really causing the problem is the complete lack of transparency. It's this idea that we're moving into what one might call algorithmic society, where machines are watching you all the time, and in many cases they're making decisions about you based on that information, and you have virtually no visibility into this. Right? And so we said maybe the way to start addressing this problem is addressing the transparency question, in making it very visible to everybody what is being tracked and how that data is being used. And we thought, okay, maybe we could start making an impact like this. And once we started to have that point of view, we realized this is sort of the intermediate step between technology and policy that we might be looking for. This is a way to collect empirical data in order to drive policy. And it's also a way to have some sort of compliance checking. And we found that whenever there has been a well-executed transparency effort, there has been a huge and positive impact. And one example that I will definitely point to is the Wall Street Journal's What They Know series, right? Most of you have seen this. It ran from 2010 to 2012. And this was huge. It was a fantastic case of investigatory journalism. And I believe the team either won or was on the finalist list for a Pulitzer, I forget. What was really interesting about this is that anytime they turned their spotlight on a particular practice or in a particular company, just that attention alone was enough to start a public conversation about it, and in many of the cases for those companies to say, we're not going to do this anymore, or for other companies who are using those services to take a look at the relationship they had with them and see if they really wanted to continue this. So just shining light on the problem seemed to be a big step forward, so we thought, notice that this ran from 2010 to 2012. They did this and they moved on. Obviously, nobody's going to continue doing this forever, because the web has millions of websites. Right? So doing this in a manual fashion is simply a losing proposition. So for this approach to be sustainable, to have a long-lasting impact, right, to permanently shift things for the better, what needed to happen is for this to be scaled up, and for it to be scaled up, it has to be automated. So this was the starting insight behind our project. We thought about this, and I remember discussing this with Solon a year and a half ago. We'd both been kind of thinking along these lines, and we said, okay, this is kind of a crazy thing to sort of launch into, but let's give it a shot. So that's what we started from, and we said, okay, we can't build this massive transparency tool all at once. Let's start with what we do have. And we looked around, and the tool that seemed at the time the most advanced about a year and a half ago was Jonathan Mayer's tool, Fourth Party. Jonathan Mayer is a grad student at Stanford, has done some seminal work in this area. And I have to say, there are a number of people working on this. I'm going to make some references throughout the talk, but also in the end, I'll say a few more words about that. So we started with Fourth Party. What is Fourth Party? It's a Firefox plugin, which if you turn on and then browse the web, it's going to record everything specifically about cookies and then a little bit more information. But that's not enough. We wanted to do a lot more when I say transparency, not just who's setting cookies and who's tracking me online, but here are some of the things we wanted to do. So I mentioned a few of these different types of uses of personal data, right? So what is common between all of these is that we can view all of them as ways of differential treatment of users based on who they are, or based on their attributes, or based on observation of their behavior over time. So we can formulate this problem sort of like this. You have a user that's interacting with a machine learning system online, right? Machine learning and data mining is what is driving all of this. And based on that, they're getting some sort of decision, some higher versus lower price, or different recommendations for products or news articles, et cetera, et cetera. And what we want to do is we have only black box access to the system. Typically, we can't talk to the people at in the companies who are doing this, and also it might be a system that's comprised of many moving parts, right, supplied by many different companies. So there might actually be nobody who's in a position to explain the mind of that machine, but can we decipher it using only black box access, using our experimental access that we have by basically simulating different types of users. So that's the sort of grander challenge that we wanted to solve. And if we could solve this, then we could sort of build a system where you have a number of bots constantly browsing the web and having some sort of long-term profiles that behave like different types of users. And then they would be able to compare prices and offers that they get and various kinds of things, and come to conclusions. And the goal is, of course, that we want to detect and measure, but also reverse engineer this differential treatment that's going on. We want to be able to explain what that algorithm is doing. And the idea is that this could lead to a variety of possible impacts: defensive tools, PR pressure, possibly regulatory action, and so on. So for this grander challenge, we knew that fourth party was not going to be enough. So we set upon the task of generalizing this and building a very comprehensive tool where a single tool, configured differently, could allow you to do a variety of experiments online and tackle almost all of the different kinds of questions that I mentioned briefly. So what does that tool look like? Let me show you a picture that describes the architecture. So this is our starting point. And what's going on here is that you have a browser that's accessing various websites and services. And what's going on is that you're sort of wiretapping yourself here. Right? Fourth party is one way of doing this. It's just a plug-in to the browser. You can also use a proxy. After a lot of experimentation, we've moved to a hybrid model where this wiretapping is happening both actually on the wire as well as sitting in the browser itself. Right? So the browser is doing its thing. We're collecting a lot of data, and we're building up the capacity gradually to log almost every type of information. This is non-trivial because what you see is a stream of bytes on the wire, but you have to reconstruct all of the structure and the meaning and the semantics of all of that information, and you have to associate it back with those simulated users that are generating all of this activity. Right? So it's a huge engineering problem. It's a systems problem also. I'll explain in a second. But even this is not enough, because who's making the browser go and do all of these things and behave like these different types of users, right? So the other key to our infrastructure, which is called OpenWPM, you can go to our website, by the way, webtab.princeton.edu. If you go to the research tab, you'll see OpenWPM and what it does. It's an open source project. It's on GitHub. You can contribute. We've already had contributions from a number of different students here who have used it for their own little projects, and in the process of doing that have contributed various capabilities back into the infrastructure. So it's already benefited from that model. So the other component, though, that we need in order to complete this picture is what is called a browser driver. And what we use for that is Selenium. What Selenium is it's a tool to automate the behavior of browsers. Right? You can give it sort of high-level commands, and then it will turn that into low-level instructions that can then be sent to the browser to make it behave in almost any conceivable way that you might want to do. But that's not a complete solution to the problem, because here is the key challenge. Selenium is intended as a tool for web developers to test their own websites. We're using it instead, we're repurposing it to do this on hundreds of thousands, even millions of websites. So the key difference there is that the web simply was not meant to be automated, and Selenium is sort of bolted onto it. And what goes wrong very often, maybe in as much as 10% of web pages, is that there is something about the automated simulated environment that doesn't quite match what happens when a regular user is browsing, which causes some script on the page to crash or freeze. And so the whole browser freezes up. So the reason that this is not a huge problem for developers testing their own websites is that they have control over their website. Right? So they can fix that script and try again, and that's how people use Selenium. But if we want to repurpose it for this other use, then we really have to solve that engineering problem. And that took, really just sweat and tears from the students over months and months, but we have finally solved that problem. We've built an abstraction layer over Selenium that allows us to very gracefully recover from these crashes, avoid any data corruption, and so on. So that was a big part of what we had to solve. We have to have data from real users that we feed into Selenium in order to have some sort of realistic simulation of people's activity. Right? So to summarize this, it falls into roughly 3 categories. Browser abstraction is one part of it, and this wrapper that we built around Selenium that's intelligent and does all these things, here's what it gives you. It gives you parallelization. And the reason that that's highly non-trivial is that the browser is an extremely complex system that depends on a number of different operating system libraries, and you have to isolate all of them from each other and avoid both obvious ways of these instances stepping on each other's toes, like shared Flash cookie repositories, right, between different browsers. If you recall how Flash cookies work on your computer, there's a single repository across different browsers and browser instances. But also more subtle ways, because the activity that you do on one browser could potentially be inferred by the website on the other browser and make them realize that these are all from the same computer instead of different users. Of course, we also have configurations where we run it on a bunch of different machines, but for maximum parallelization, we do often need to run it on the same machine. So we do have to solve these sorts of abstraction and systems challenges. We need to do crash recovery, and we've also built something pretty cool that we call a log and replay architecture. There's a relatively abstract API between this component and this component, which means that we can record our actions. And this is a relatively portable format. We can replay them later. And so, so this is still in progress. It doesn't work perfectly, but we're getting there. And the idea here is that you can run longitudinal studies. You can monitor how things change over time, and different people can reproduce studies, because that's another huge challenge in this area. A lot of people do a one-off study because the incentive structure of academia is built that way, right? You do a paper once, you publish it, you move on to the next thing, which is great for writing papers, and it definitely has had a lot of positive impact. But if you talk about what the web needs, there's a bit of a mismatch there, and we wanted to solve that problem. And we've made a lot of progress toward that. We also need to model users, give the machine capabilities like automatically logging into websites. This is a machine learning problem. Again, we've made a lot of progress here, and it's good enough that we've run studies using auto login, but it's not quite there yet. We're continuing to work on that capability. We need the machine to behave realistically when it's on a page, move the mouse, scroll around, that sort of thing, and also different browsing profiles. What does an affluent user visit typically? What does a less affluent user visit, so that we can measure the differences between these scenarios. So we've built all this, and this last part is not quite a technological component, but we've come up with a comprehensive set of methodological standards for attributing causality, which turns out to be a really tricky problem. Is this change that you saw on the website simply because of A/B testing, or is it because of something that you did on the browser, right? So, and the infrastructure does do a few things to make those things easier, but ultimately it's up to the researcher or the analyst to be versed in those statistical knowledge and be able to execute the study. Okay, yeah, did you have a question?
How browser independent is it, or are these various things?
So we've run it sort of on a small scale with Firefox and Chrome, but we've only done large-scale studies on Firefox, so I'm sure that if we tried to replicate our results on Chrome, we'd run into a lot of problems, and then we'd have to fix that. It's harder with Internet Explorer because certain types of APIs are not supported. But I feel that as long as we have a couple of different browsers that we can run full-scale studies on, I think we'll be in a pretty good spot. Cool. So that's the infrastructure that we've built. Let me tell you about some of the cool things that we've found using this. Cool, but also scary. And to emphasize that it's really the single infrastructure, configured a little bit differently, but also with different analysis scripts, that are getting us a wide variety of results that we might want to know. Three very different categories: security, privacy, and what I'm calling fairness, but we'll see what I mean by that. And so if you go to our research page again, you'll see about a half dozen papers, some of them published, some of them under submission. So there's going to be a little bit of a whirlwind tour of some of those, but you're welcome to go online and look at our papers and FAQs and other materials that we've put out. So I want to start with something very interesting that I'm calling malvertising, which Pete is working on, and he's in the back. You're welcome to talk to him after the talk. So here's what malvertising is about. Let me start by asking you this. So when you log into a website, you typically use a username and password, right? So what protocol is that? Is there a standard protocol for that? So it turns out when you typically do this, there's no protocol. Each website sort of implements it using whatever library that they care to use, even though there is, in fact, a protocol in HTTP. It's just that nobody ever uses it. And this is the HTTP authentication protocol. And interesting things always happen when there is some protocol hidden somewhere that everybody has forgotten about, Heartbleed, right? And then somebody discovers that it has some very unintended purpose, and you can use it for compromising security in interesting ways. So there is an HTTP authentication protocol, and if you haven't seen it, this is what it looks like. This is my wireless router. I took a screenshot this morning. And so that's typically the kind of, so a wireless router doesn't want to have a whole lot of web libraries and so on, so it does the simplest thing. It uses this protocol. This is what it looks like. To the user, it just looks like a regular username and password box, right? When you see a dialog box like this is what's going on. Your browser is sending a request to get a resource on the server. The server sends back 401 unauthorized. And it tells the browser that the user doesn't have access to this resource, and so it puts up a username and password box. Yeah, so far so good. Here's a question. So when you browse the web, you go to some website, maybe CNN, and there's a hidden pixel on there, maybe DoubleClick or some other website like that. It could be an invisible one-by-one image or a variety of other technologies are used for this, right? So when your browser accesses CNN, what your browser is automatically going to do is going to send a request to the DoubleClick server or whatever server. What if that request returns a 401 unauthorized response? Do you think there will be a username and password box presented to the user or not? Guesses? No.
There must be, because otherwise it won't be interesting.
Otherwise, I wouldn't be talking about it, right? So Mike is way ahead of you, Josh. I'm sorry, but yes, but in a common sense way, you would expect that there is no way that this would lead to a dialog box, but in fact, it does. And we did a study across all different browsers, and in many cases, it leads to a dialog box, even if that thing is inside an iframe. An iframe, it's the web sandboxing mechanism, right? It's supposed to completely isolate those origins from each other and not let one interfere from the other, let alone put up a username and password box, which the user is going to think is coming from CNN or whichever website they're visiting, right? So this is an egregious breach of the user's mental model of web security. So here's what we're doing with this. This is a known bug. We've had trouble convincing browser vendors to change this, even after we did a study showing that even under many unexpected conditions, browsers continue to put up this box. So what we're saying is, this is the study we want to do. So sometimes this pixel is coming from DoubleClick, and DoubleClick is, and a variety of others. It could be an ad exchange or an ad network or something like a demand-side platform. Those are parties that CNN or the publisher or whatever website you're going to has a relationship with. So they have some knowledge. There is some accountability. The first party gets into trouble, they can sort of try to kick them out of their website and so on. But here's where it gets really complicated. These ad exchanges and networks and supply-side platforms are encouraging advertisers to put their own pixels along with the pixel that's coming from the network itself. And so who could this advertiser be? It could be somebody like Ford. It could be you, right? $25 is about all it takes is to become an advertiser and to send your own third-party advertisements to major websites. And you could stick that pixel on there, and the user is going to get a username and password box that they think is coming from CNN. Right, so that's a much bigger problem. So we're using our infrastructure to do a measurement study to measure the scope of that problem. And when we get that data, we feel much more confident that that's going to convince browser vendors to finally fix this problem. So that's a security thing we're doing. Let me tell you quickly about one more security thing before moving on to some privacy problems we're measuring. I'm just trying to illustrate the diversity of different things that our platform is able to measure. So this is study of how secure HTTPS is. And Joe Bonneau, who's a postdoc, and Michael Cranch, who's a master's student, worked on this, but they used the same infrastructure, OpenWPM, that I've been talking about. So what they found is that a variety of websites are trying to improve the security of the HTTPS protocol that keeps websites secure, that encrypts it against eavesdroppers, by adopting some add-ons to this protocol that are supposed to improve security, like strict transport security and key pinning. But they were able to do a measurement study that showed across the web that developers simply don't understand the correct logical ways of using them. And here's just one example. And here's the cool thing. Even though it's really hard to imagine putting this into every tutorial on HTTPS, but now that we have this tool, here's a future you can imagine. You're coding a website, you put it live, you get an email from an automated bot that's scouring the web for security problems. Because we know that the bad guys are doing this. There's a way for us to be ahead of them, right? So that's the future for web security you can imagine, and we think that this tool is going to get us closer to that goal. I want to emphasize that this is not going to catch all types of web security problems, so we're not even trying to catch, for example, cross-site scripting using this, but there is a certain large and important class of web security problems that can be detected in this fashion. So let me tell you about some of the privacy stuff we're doing. This is a study that we did in collaboration with people at KU Leuven, and Steve was our lead. So I'll very briefly say that what we found is that there's a very sticky type of tracking online called canvas fingerprinting. And what I mean by sticky is that these are very hard to detect in normal ways. Your browser doesn't give you a very good interface to look at it, to block it, to control it, and so on. What canvas fingerprinting does, I know this looks like I messed up my slides. It draws an invisible element on your screen. And in that invisible element, it renders a lot of text. And you can see that this is a pangram. Why might they be doing that? The reason they're doing this is that at a pixel level, the way in which this text is rendered by different machines is going to be different, because the rendering depends on your browser, I think your JavaScript library, your graphics card, and your whole underlying hardware. It has a certain number of bits of entropy. It can't necessarily distinguish every person on the planet from each other, but you can add it to other methods of fingerprinting. I won't say too much about what we found, but what we found was just so surprising that yeah, it led to a lot of change online. We found a number of websites saying, in response to our study, okay, we're going to stop doing this because there was a huge amount of outcry from users, and there were just hundreds of tweets saying, I didn't know that there was a script on my site that did canvas fingerprinting. I'm going to remove the script, and so on. So every time someone does a study, we see a huge impact. But what we want to do is to automate that and do it on a continual basis, and also make it in a form that's much more accessible to users. And I'm going to say a little bit more about how we're trying to address those questions. So very quickly, one other privacy problem that we're investigating is based on reports that the NSA has been piggybacking, as it turns out, on advertising cookies. So we decided to look at if there is, if these reports are true, if there's an adversary that's piggybacking on advertising cookies through wiretapping or passive eavesdropping on the network, what can they find out? And the answer, again, completely took us by surprise. Again, there's a paper on it. I'm not going to go into too much detail on that, but I just wanted to point out another completely different type of privacy study that, again, our platform makes it very easy to run on a very large scale. So let me get to something different now. This is a question about fairness. That's one way to put it. What it more broadly represents is a question about algorithmic personalization of your online experience. And specifically, we wanted to look at the worries about the filter bubble, the idea that websites are customizing your online recommendations to feed you things that you're ideologically inclined to and putting you in this bubble of self-reinforcement. Right? And so here's what we decided to do. Our hypothesis was simple. We tested 8 or 9 different major newspaper websites. This is the BBC. We did most of the major ones. What we wanted to look at is if there's consistently shown an interest in reading sports articles. That's almost all that they're ever going to. Then over time, does the website change to recommend more sports? Here's the cool thing. The filter bubble, along with a lot of the others that I've talked about, is an area where there are a lot of concerns among civil liberties advocates and a variety of others. In fact, something that I hear from Solon and many others is that one of the recent things that have happened is that the civil rights movement has been coming together with people who are talking about applications of big data to analyze the effects of online big data and personalization upon civil rights. So all of this is happening. What is missing from this equation is data. Every time you do a measurement, you get some kind of surprise. And boy, did we get a surprise here. So what we found is that there is, in fact, personalization going on. We do see, when you browse all sports articles, the articles that are recommended to you change. But it's not something as clear-cut as you would expect. In some areas of these websites, you find that you get more sports articles recommended. In other areas, you get fewer sports articles recommended. And the magnitude of the effects is not nearly as high as you would expect, even though we have enough to rule out the null hypothesis. 300,000 web page visits, and so we have a pretty large N here. So based on this, I can say 2 things. We're not able to fully reverse engineer the algorithm. We do know that whatever personalization is happening simply does not fit into this simple story. That is just not what is going on. So that much we know. And then once we found this, we started looking at other such areas where people have had concerns. And we started finding similar things. Here's a paper. Again, they did a massive study. They gave them every possible opportunity to tailor prices. No evidence of such tailoring. None. There's a study measuring the personalization of Google web search. Again, similar results. Sometimes there is some tailoring going on. It's mostly based on location and other attributes that you can change easily. Let me clarify a few things. These negative results does not mean that such personalization is not happening, but something we can infer is going on that we don't quite understand. The narrative that we hear of pervasive online personalization that's systematically based upon your identity and your behavior over a long term, we're not quite seeing evidence of that, and there is something missing. Now, there could be a number of different explanations to this. One that I think might have some validity is that websites are not tailoring the prices that they show you online, but when you walk into a store, for example, there are apps that automatically give you a coupon or some kind of offer based on who you are, based on your physical world behaviors. And we think maybe there's a lot going on in these spaces. There's something fishy we don't quite understand, and the simple narrative is simply unsupported by the evidence that we have so far. So just to reinforce the point that there is something that we don't know, as early as a decade ago, Andrew Lisko wrote this amazing paper. A huge amount of money has been poured into tracking infrastructure, right, especially third-party tracking, and all of this information is being collected. Supporting behavioral advertising can't possibly be the economic justification for all of this activity. But that's what he believed, and that's what a lot of people continue to believe. And one interesting piece of evidence for this is that when there has been public or regulatory pressure around third-party online tracking and data collection, what companies have said in response to placate users has been, we'll stop using that tracking data for behavioral advertising. Which makes no sense from an economic perspective if you're of the belief that the purpose of all of this tracking infrastructure is behavioral advertising, because why would companies be willing to give up what is supposedly the cash cow but still retain the data instead of stopping the tracking altogether, given that it's quite expensive to do this tracking and to have all of this infrastructure in place. So people have been consistently saying that the reason for tracking must be something else. We and many, many others online, we're not quite finding the evidence that we thought we would. So yeah, that's at an interesting point. So what we've tried to do is bring data to this conversation, to this area of huge public interest. I want to say a few things about what's next on our plate, where we're going with this, what the vision is. Let me give you a few examples. So the first one I'm going to talk about is what I'm calling first-party accountability. So what is this all about? So remember that the project is called Transparency and Accountability. I've said a lot about transparency. This is a little bit of the accountability part, a comprehensive single click to identify security and privacy problems on their own site. This doesn't quite exist yet. There are some companies who are trying to do this, but these tools are not supported by the kind of crawling infrastructure that we have, and so they're not producing the same kind of results. So this is something we want to build. And if we build this tool, which doesn't exist, here's the cool thing that can happen. We want to be able to change public perception and just the prevailing policy sentiments to say, you need to own up and you have to be responsible for cleaning that up. You can't just say, oh, we just included this script on our site. Oh, it stole all your data? I didn't know that happened, right? So that's not going to be an acceptable answer. Right now, we can't say that because the whole system is so opaque that it's hard for even a well-meaning publisher site to be able to get this information about their own website. But we want to change that. So again, this is an example of the interplay between technology and policy. Combine a technological solution and a policy or an enforcement push. And so I think that is what is going to lead to lasting change. So another thing we want to do is what we're calling a web privacy census. We want this to, I was saying a little bit about this before, since we are getting toward this notion of one-click reproducibility, we want all this to be web scale, we want it to be comprehensive, we want it to be longitudinal, we want people to be able to pull up a website and get sort of a scorecard for it and be able to follow what it's been doing. Paul, do you have a question?
I did, but I didn't mean to raise my hand.
Okay.
Telepathy. The question is, are you going to aggregate this data into some kind of index numbers?
At the moment, we're facing a big data problem because our data sets are already in the gigabytes or tens of gigabytes, and that's only the tip of the iceberg. If we do this longitudinally, we're going to generate that much data every week. And so one of the challenges that we're facing is if we're doing it longitudinally, the data that we get has a tremendous amount of duplication. The same data every week with some interesting changes. There's a good underlying database for time series data. So that's a question we're investigating. Once we have a better handle on that, we'll be able to make this work in real time and very quickly across a web scale data set. We can't quite do this yet. So another direction we want to go in is a machine learning based privacy tool for browsers. And we've started putting some work into this, but it's, again, future work that's starting to happen. So here the idea is, even if you say, I don't believe in all this policy nonsense, I don't trust the government or self-regulators or whoever, the only thing I'm interested in is this tool that works better for me that I can install in my browser that is going to block tracking and not have too much of a hit on legitimate functionality. Imagine if you can do this. Imagine if you can start from crawl data to identify what's a good versus bad behavior and not good versus bad actor, and try to, instead of generating this huge manual list, what if you could dynamically identify these behaviors that you want to block. Right? We think we're going to be able to do that. We think we're going to be able to run these things on a web scale. Here's a version of my instrumented browser that has no blocking tools. Here's a version of my browser that has a blocking tool. I'm going to be able to see when something breaks and feed that back into my machine learning algorithm in order to do a better job of blocking exactly what I want to block. A new privacy tool from EFF called Privacy Badger. We're starting to work with them to try to see if our crawl data can help make that tool a lot better. And of course, you'd have feedback coming back from users where the tool is deployed. So we think this is going to be a new generation of blocking tools, really. So another direction we're looking at is mobile. And I know that this looks like a completely gratuitous picture of a monkey, but it's not completely gratuitous, and I'll explain why in a second. So I think the primary privacy challenge with mobile when you're using apps on your smartphone is that we know that a lot of these apps require access to lots of different types of data on your phone, whether it's your photos or SMS or whatever, to do their job. But what you're worried about is that in addition to using it for its claimed legitimate purpose, it's also going to ship it somewhere else, sell it on the side, or send it back to its server, and so on, right? And so the permission model of smartphone operating systems are simply unable to capture this difference. So what we want to do is use measurement results, do this on hundreds of thousands of apps, to answer all possible questions of the form: is this app sending this type of data from my phone to one or more servers, and to get a list of all the different parties that it might be sending that data to. And then people can easily match that to the claimed legitimate use or to the privacy policy and notice whenever there's a violation. We also want to be able to say, is my activity in one particular app leading to targeted ads based on that activity? So the fundamental challenge in making this happen is that you have to trigger all or most of the functionality of the app, right? And apps are not inherently programmatic, just like the web resists automation. Apps resist automation even more. So you need a tool that's going to explore the functionality of the app in an intelligent way. And the technical term for such a tool is a monkey. So we're starting from an existing tool called Apps Playground. We're making some improvements to it in order to address questions of this form. And I think this can make a huge difference to the whole app privacy ecosystem. We've started collaborations with a number of different types of people. And let me explain sort of the vision that I have for where I want this to go. Eventually, I want us to be in a place where security problems on websites are as obvious as a malfunctioning car, as the check engine light on your car, and that feedback loop will be instantaneous, and so there will be pressure on websites to fix that privacy problem. Because we found time and again that every time that users actually understand that something's going wrong, that something's affecting them, if they even begin to make their displeasure known, the market mechanism is still very much working. What is broken is this information asymmetry, because either the information is not available to users or not in a usable form. And I want to say we have a way to go before we get to that point, but we're building the tools so that it can be directly integrated into a website. So that's where we're hopefully heading toward. And we're trying to establish partnerships with a lot of different types of people. Privacy advocates, obviously, the results that we produce are very useful to them, but also we learn from them what are some research directions that we want to go. And developers of these tools, the press, of course, questions that we want to explore, we learn about from press results, right? Because there might be an insider who's talking about something, and so there might be a press article about, hey, this kind of activity is going on. Onboarding is something, one of the things we want to look into is something that should upset a lot of people. Why is nobody looking into this? And we can say, why don't we measure that question? The reason that's crucial is that we need a hypothesis that we need to feed into the tool, right? The tool can't formulate the hypothesis, and that's why these external sources of knowledge are useful to us. Obviously, if there are hackers out there who want to participate in this project, open source developers, we'll give you lots of suggestions on things that we can work on together. Like I said, we want this to be in a form that's more directly usable to the public, so we're getting there as well. And we also want to talk to companies. Many companies tell us they're all for greater transparency. That's great, and I think that's the right approach. So far, one of the responses that we've gotten is that people are willing to have transparency, but they interpret transparency as, we'll tell you what we're doing in our privacy policy, and you have to take our word for it. So I want to make that difference very clear, that people use the word transparency in different ways. And for us, what transparency means is that promises that are at least somewhat technically verifiable by external auditors and everybody can agree upon. And we have a lot of suggestions for how we can work together with companies to achieve this, and we hope to talk to them and form some partnerships in the future. And so again, we're far from the only group of people who's working on results like this. There are a number of them that are listed on the bibliography page of our website on webtap.princeton.edu. It's one of the things that I'm hoping to do with this is to sort of form an identity for this community that web transparency is important. It's not just about traditional web security research, and while there are ethical concerns about fairness over here, those communities have to meet in the middle and use these technical infrastructures to have a more informed public debate and better policy and so forth. And I think this is the beginning of that, and I think it's going to be an exciting time. Thank you.